AP Statistics. In this video, we are still in Unit 3, looking at our notes, and we are going to continue with example 13. So we have a group of biology students randomly assigned 100 corn seeds. They are planted at a depth of 1.5 inches or 3 inches. Explain why it is not necessary to include a control group of seeds that were not planted in the soil. Well, obviously, I've got the answer right here. So remember what the point of a control group is. The point of a control is to provide a baseline. Well, if we're only concerned with planting these at 1.5 or 3 inches, I already have my comparison. I'm going to compare the ones that are planted at 1.3 inches or 3 inches. Now, the only way I would have a control group here, let's say I have a farmer who has been planting his corn seed at 4 inches for the better part of his life. All right, it's been pretty consistent. He plants them at 4 inches, but lately his crops have not done very well. So the 4-inch depth could be his control. So he could, the farmer could use that as a baseline and have a control group of 4 inches and then another group of 1.5 and another group of 3 to compare everything to his control. But for this particular situation, we're not told there's a control group. There's not any indication that we need one. We are just comparing corn that is planted at 3 and 1.5. All right, so now let's skip down to example 15. So pause the video and read this so you'll know what's happening here. So when we look at blinding, so what it means when we're asked to explain what it means for this experiment to be double blind, well, notice in the problem, Rivers would have his friend prepare the caffeine drinks, and then he would give the drinks to the subjects. So that means the subjects don't know what they're getting, and the researcher also didn't know what subjects were given either. Okay, he knew they were given a caffeine drink or a placebo, but nobody knows which one they're getting. Part B asks, why was it important for this experiment to be double blind? Well, anytime you think people are going to behave differently if they think they're getting something, or if you think the researcher is going to treat people differently based on what they know they're getting. So I've got it written out here. If subjects knew they were drinking caffeine, he wouldn't be able to tell if they had truly improved their work output due to the caffeine or due to their expectation of getting caffeine. And if Rivers knew who was receiving what, he may have treated one group differently from the other. So it's going to make it difficult to know if the caffeine was the cause or if it was something else.